Guys, this is the lesson for Wednesday, October 24th, and this is lesson 6 from the Green Book, and it's called Construct Functions. What we're going to be able to do throughout this lesson is interpret the rate of change and also find the initial value of a function. Remember from yesterday that the initial value is the same thing as the y-intercept. Okay? So here's how this is going to start out. This first example, Grace is planning to have her birthday party at a skating rink, and the rink charges a party fee plus an additional charge for each guest. And they want you to write a function to represent the situation and then use that function to find the amount the skating rink charges for the party fee. So if we look at our table, let's always start by finding the rate of change on our table. So this looks like for each guest, so as the guests increase by 1, the total cost is increasing by 3, right? So my rate of change is $3 per person. But I know that that's not all, because for one person it costs $53. So if I work my table back to 0 guests and I subtract 3 on this side, then I have a $50 cost that's not related to the number of guests, so that should be the fee for having the party. Okay, so we've got our rate of change, which is $3 per person, and then we've got a $50 initial value or one-time fee to have the party there. So our function would look like this. Total cost is going to equal $3 per person plus the $50 fee. So now you could use this function, plug in any number of people that are coming to the party, any number of guests, and find out what your total cost would be. It says right here in the example above, the party fee is the initial cost. The initial value of a function is the corresponding y value when x equals 0. And you can find this from either a table, a graph, or words. So let's write ourselves a little note here that the y-intercept is the initial value. That's the starting point. Okay? All right, let's look at another example. Here we have Ava, and she's saving money. We can look at her table and see that she is saving $20 per week. We don't know yet how much she started with, though. And it's asking you to determine the initial amount of money. So how much did she start with before she started saving $20 per month? Now we can see that $20 from the table. They use the slope formula to show that you can choose any 2 points, use x2 minus x1 over, y2 minus y1 over x2 minus x1, and you can see there that your monthly savings would be $20. So if we use that information to work backwards on the table, you can see the current table only goes to 3 months. So if we work backwards, continuing the change in x and continuing the change in y, but this time we're subtracting, you can see that when we get to 0 months, she had $50 to start with. Now let's see if we can do one. The table shows the monthly cost of sending text messages. So we're going to look for the initial cost of the phone plan. So you first have to determine the rate of change in the table, and I can see that this is increasing by 20 cents for every text message that's sent. So all I have to do is work backwards on my table. I'm going to try to squeeze it in up here. If I go back to 4, to 3, 2, 1, and 0, I should be able to see what the initial cost would be. So remember, I'm going to subtract 20 cents each time. So that would be $10.30, $10.20, $10.10, and then let's start that again. We're subtracting 20 each time. Oh, this is my problem. It's a 10-cent change. Sorry about that. So then if we subtract 10 cents at number of messages 4, we get 1040, then 1030, then 1020, 1010, and finally at 0 text messages, we have $10. So the initial cost of the plan before she sends any text messages is $10. And then for each text message, she would add 20 cents to, I'm sorry, I'm still saying 20, 10 cents to that. Okay? Now let's take a look at this next example. This is where you've got a shoe store that's offering free points to customers who sign up for their rewards card. So for each pair of shoes the customer buys, they earn an additional number of points. The graph shows the total number of points earned, and they want us to determine the initial number of points. So how much points did they start with? How many points did they start with on their card before they started earning points? So you can see they chose 2 of the points here. They chose 490 and they chose 260. And they used the slope formula to find out that they were earning 15 points per pair of shoes. Now, if we use that rate of change and work backwards on the graph, just like we would a table, you subtract 15, and then you subtract 15 again, and you find out that the initial value, or the amount of points initially on the card before they started earning for shoes, was 30. So you can work backwards on a table or a graph and get that initial value. All right, let's take a look at this one with music. Music Incorporated charges a yearly subscription fee plus a monthly fee. The total cost for different number of months, including a yearly fee, is shown in the graph. We want to look for that yearly subscription fee. Okay, we can tell that it's going to be between $10 and $15, but we don't know exactly without doing some math. Okay, so if we want to use the same strategy by finding the rate of change, we can choose these 2 points right here, or we could use the bottom 2 points if you want to. 18 minus 15, that's change in y, over change in x. And that's going to be 3 over 1, and that means $3 per month. Okay, that's my rate of change. Now I'm going to use that, though, to figure out what this initial value is, because that's going to be my subscription fee. So all I have to do is subtract $3 from the $15 that's in the point 115, and I will get $12 for the subscription fee. Okay, so I knew that at 1 month they were being charged $15, and so I knew 3 of that was for 1 month, so the rest of it, the rest is 12, would be the initial subscription fee. Okay, let's look at the next example. Now this is where you're going to be able to analyze words, and I'll just go ahead and tell you the easiest way to do this is to make a little table so that you can see how the numbers line up. When it says respectively, that means in the same order. So 2, 4, 8, and 16 are the weeks, and then the number of photos are 48, 72. That means at 2 weeks she had 48, at 4 weeks 72, and so on. So that's what respectively means. So it says to write the week number and the number of photos as ordered pairs. So what they did was they wrote it as ordered pairs, and then they chose 2 of those points to find the rate of change. So what they found was that she had 12 photos that were being added per week. So to use the rate of change to find the corresponding y values, they wanted to know what was the initial number of photos she had in her album. So we have to work backwards and you'll see that the initial number was 24. When x equals 0, y equals 24. Okay, let me show you how I do this on this one. We have a zoo, we again have total cost, and we have number of hours. Okay, so what I would do is I would put my hours on one side, so 2, 3, 4, 5. And my cost, just make a little sketch of a table, would be 7, 9, 11, and 13. Okay? So I can see here that my rate of change is adding 2 each time, right? So if I want to work backwards and get to 0 hours, that's where I would find the rental fee. So 0 hours. So if I go back to 1 hour and then to 0 hours, subtracting 2 every time, you'll see that at 0 hours there's a rental fee of $3. So all you have to do is treat it like a table and work backwards. The function for this one, if I was going to write the equation, it would be y equals the $2 per hour plus the $3 rental fee. So see, once you understand what's happening in the problem and you see the rate of change and the y-intercept, it's very easy to write the equation. That'll actually get us ready for what we're going to do next week. Okay, so let's work a couple more of these. The homework is going to start with number 3 in this packet. So let's look at number 1 and number 2 together. Number 1 says, a science center charges an initial membership fee, and then the total cost of the membership depends on the number of people included. So we're going to use that table, use this table to show the memberships to determine the initial fee. So again, you could do slope formula, but really, if you will just look at your change in y right here, it's going up by 15. And then if you will look at your change in x, it's going by 1. And so my rate of change is $15 per person. But remember, I want to work back to find that initial fee. So I'm at 2 right here, so I've got to jump to 1 and then jump to 0. So I'm going to subtract 15 and get 50, and subtract 15 again and get 35. So the initial fee would be $35. It's very easy to work on a table and go backwards. Okay. Now let's take a look at how we would do this on the graph. As part of the grand opening, an arcade gave out free tokens to the first 100 customers. The graph shows the number of tokens they received for each dollar spent at the Playmore arcade. So find the initial number of free tokens. So we first need the rate of change. So I'm going to use my 2 lowest points, and I'm going to do my slope formula. 38 minus 32 over 6 minus 5. And that ends up being 6 over 1. So what that tells me is they get 6 tokens for every dollar spent. Now, how are we going to use that to get back to the initial amount of tokens? We can tell it's close to 20, but we don't know exactly what it is without doing the math. So we can go backwards. Again, we can make a little table. If we know that $5 spent gives you 32 tokens, now I can use my rate of change that I found, and I can go backwards on my table in order to find out what it was at 0. So I'm going to subtract 6 tokens every time. So I go back to 26, to 20, to 14, to 8, and then finally to 2. So this 2 tells me that even with $0 spent, they got 2 tokens. Okay, guys, so to continue with this one, we were almost finished. When we work our table all the way back using our rate of change, we find that initially they started with 2 free tokens to start. Now, don't be confused because the graph doesn't seem to match that. I said earlier that it looks like they started with near 20, but I realized what happened was when they used the line break here to abbreviate the graph, they don't have the other numbers. Think about it. This would be 3, 2, 1, and 0 would really be over here, and so our line would continue down, and it would actually cross the y-axis at 2. So don't be confused by that graph. When you have a line break, you have to be really careful. Okay, so your homework is 3 through 8. Read carefully. You're probably going to want to work on another piece of paper because there's not room on this packet. And good luck.